Hello, everyone. Welcome back. Today, I want to talk about the half angle formula. So basically, the goal is to understand them and then also be able to use them to simplify, find the values of trig functions and simplify expressions. So here are the half angle formulas. So if you've seen my previous videos on the sum of difference formulas and also the double angle formulas, what these formulas do is give their main advantage, if you know for some angle A, the value of the trig functions for A, the exact values, and you can use these formulas to find the exact values of the trig functions for half that angle, or A divided by 2. Now, let's take a look at each expression. So the cosine and sine of A over 2 are both very similar. The only difference is the cosine, you have 1 plus cosine at the top, and the sine is 1 minus cosine. So make sure you're really careful which one you use. And then also we have expression for the tangent. And actually, you can get this expression for the tangent by dividing. Of course, tangent of anything, any angle is sine over cosine. So if you divide the sine expression by the cosine expression, you actually get this expression here. Now, if you notice in these two, in both the sine and cosine, on the first one of the tangent, you have a plus or minus. So this is something that you may not have seen before in a identity or in a formula. But basically, you have to determine then plus or minus which one you use. Determine that based on the trig function itself, cosine, sine, or tangent, and then also the quadrant, which quadrant the angle A over 2 is in. Knowing those two things, then you can decide whether it should be plus or minus. Now we have two more expressions for tangent of A over 2, and all three of these are equivalent, but these don't have a plus or minus in front of them, last two, so actually it's not that step of determining which quadrant you're in and what the sign is isn't required. By doing this correctly, they'll supply the right sign themselves. And also, if you want the find like cosecant, secant, or cotangent of A over 2, then use reciprocals of the correct trig functions. Okay, let's look at some examples and practice with these. What we want to do then is to find the exact value over here. So let's make those our directions. So find the exact value. Okay, so number 1. Let's say we have the cosine. I want to find the cosine of 165 degrees. Now, the cosine 165 degrees, that angle is not an angle that is involved with what you might commonly see on the unit circle or a special triangle. So what we're going to do then is we're actually going to take this angle. So we're going to use the half angle formula. And what we're going to do is we're going to say, well, let A over 2 be equal to this. And so then we want to find the angle A, multiply that by 2. So 2 times 165. And I believe that is 330 degrees. Check that on your own. Right, it is 330 degrees. Okay, now that value is commonly involved with reference angles and unit circles. So if we do 330 degrees, let's actually graph both of these. Here's 0 degrees, 90, 180, and 270. So our original angle is 165 degrees. That's in quadrant number 2. And then this angle is here somewhere in quadrant number 4. Okay. Now, so what we can do then is we can use the formula half angle formula, which says that the cosine of A over 2 is equal to plus or minus the square root of 1 plus cosine of A over 2. Okay. Now we need to determine whether we need to use the plus or the minus. All right. So 165 degrees is, we said, in quadrant 2. Okay. And also in quadrant 2, cosine is actually negative. Since we're on the left side of the y-axis, cosine of theta, or any angle, is negative in quadrant 2. Okay. So we're going to use the negative part, the negative formula, okay? And so let's plug all this in. So we're going to have the cosine of 165 degrees is equal to the negative square root of 1 plus the cosine of 330 degrees over 2. Okay. Now, 330 degrees, that's a fairly common value you can find on a unit circle, okay, or using reference angles. And if you find the cosine of 330 degrees, so if you have a copy of the unit circle, then 330 degrees, the cosine of that is the square root of 3 over 2. Okay, so this is equal to square root of 1 plus the square root of 3 over 2 divided by 2. Okay, now we also want to practice with finding the exact value, or if you're simplifying this. So what we're going to do first is let's actually combine the terms of the numerator of our fraction. And so 1, of course, is the same as 2 over 2 plus the square root of 3 over 2 to get a common denominator. Okay, and then let's combine that. And so we have 2 plus the square root of 3 divided by 2. Then that's also divided by 2. Okay, remember this whole thing, let's actually make this clear. This whole thing is actually under the square root. Now, what we can do here is what's under the square root. Remember, if you're dividing fractions, multiply by the reciprocal of the denominator. And so this is all still under the square root. And actually, I have to be careful. I forgot my negatives. Always be careful of that. Okay, I have to carry the negative through. Then 2 plus the square root of 3 over 2 times the reciprocal of 2 is 1/2. Okay, and so that's going to be negative the square root of 2 plus the square root of 3 over 4. And actually, we can simplify this a bit more. A rule says that if you're taking the square root or any root, any radical of a fraction, you can break that up into the radical of the numerator, 2 plus the square root of 3, over the radical of the denominator, square root of 4. Of course, we know the square root of 4. So finally, this, the cosine, 165 degrees, is equal to minus the square root of 2 plus the square root of 3 over 2. Okay. Now, let's also approximate that, because obviously that's not a value we're going to use all that often. If you ever use this in real life, you can check this. So let's go use Desmos. Okay. So you can also use a calculator. So negative, just square root, just you can just type SQRT. Then here we do need parentheses. So 2 plus, then once again, SQRT, 3. Okay. Use the arrow to get under the radical sign, that particular one. Use the other parenthesis, then divide this by, just divide by the whole thing by 4. We leave it that way, it's perfectly fine. And this is approximately negative 0.97. Okay. Now let's check and make sure that's still correct. Let's actually, first off, make sure my Desmos is in degree mode. I'll have to change it. So to go between degree mode and radian mode in Desmos, go to this little wrench. Down here, it's actually usually defaults in radians. So click degrees. Okay, once we do that, and then let's do that. So cosine of 165 degrees is exactly the same. So approximately negative 0.97. Okay, good. So what we did then is we found the exact value of cosine of 165 degrees using this. Okay, and then we verified that it is correct. Okay, and also then if you want to know like the secant 165 degrees, it's just simply the reciprocal of this. Okay, look at our next example. This time let's do one involving sine. So number 2, say I want to find the sine of 195 degrees. Okay, so like I did before, what we're going to do then is we'll say let a over 2 be equal to 195. This is also not a special triangle value or unit circle value. Then, of course, then to find a, just multiply the top and bottom, multiply the top by 2. So multiply by 2. 2 times 195. And that's going to be 390 degrees. Now, you notice that is obviously greater than 360 degrees. So let's find a least positive coterminal angle. So we can use unit circle values, okay? So to do that, then just take 390 degrees minus 360, and of course that's just going to be 30 degrees. So let's draw a picture of this. 0, 90, 180, 270. So right here is approximately 30 degrees. And then if we go all the way around and back here, then that is, of course, 390 degrees. And then actually 195 is actually in quadrant 2. That's 195 degrees. Okay, that's our original angle. All right. So once again, as we did before, so we're going to use a half angle formula. So the sine of a over 2 is equal to plus or minus the square root of, this time it's 1 minus cosine of angle A over 2. Now, in the same thing, we need to figure out which quadrant we're in. So 195 degrees, of course, is in quadrant 3. And then sine in quadrant 3 is negative in quadrant 3. Okay. So in this case, we're going to use the negative version. Okay. So if we plug everything in, we have the sine of 195 degrees is equal to the negative of 1 minus the cosine of 390 degrees over 2. Now, once again, since we found a coterminal angle, since 390 degrees is coterminal with 30 degrees, they have the same values of the trig functions. And so this is going to be the same as negative square root of 1 minus the cosine of 30 degrees over 2. Okay. Now, let's plug all that in. And so actually then 30 degrees minus, once again out front, we do, once again, check, a special triangle or unit circle, 30 degrees, the cosine of 30 degrees actually turns out to also be the square root of 3 over 2. Okay, so this is very similar to what we did above, all right? And that's just a coincidence. Not entirely a coincidence, but that's a coincidence here, okay? So this one was 1 plus the square root of 3 over 2 on the inside. This one is, and also is a minus. This one is simply a here, the same thing with a minus. And so actually, it's going to be the same as this, except with a minus here, all right? So actually, we can make life simpler. We don't have to go through all those details, okay? So this is similar to number 1. And so we'll just go ahead and say that the cosine of, sorry, not the cosine, the sine of 195 degrees is equal to minus the square root of 2 minus the square root of 3. Actually, sorry, that's actually too big. Over 2. So once again, it's the same as the expression we have for the cosine of the previous one. This is square root of 3 over 2. And since the formulas are so similar, the only difference is this was a plus, this was minus. And so it's going to be the same as this, except a minus here instead of a plus. So to see how to reduce that to this, you just follow that same pattern above. And so that's our value. Now, once again, let's approximate this and make sure we're correct. Let's go back to Desmos. And actually to do that, I'll just copy this and paste it below. And then let me change this sign to minus. Right. And that's approximately negative 0.26. Now, let's also check and make sure that's correct. So if I do the sine of 195, right, exactly the same. Okay, approximately negative 0.26. Okay, Also, let me check, make sure I have enough space. Yes, I do for the last one. Okay, now let's do one more involving tangent. And this time for number 3, let's do the tangent of pi over 12. Let's do it in radians. Okay, same thing. So we're going to let a over 2 be our pi over 12 in our formula. So we need to find just a, multiply this by 2. So a is equal to 2 times, oops, pi over 12, not pi over 2, I'm sorry. So pi over 12, and that's going to be pi over 6. And that is one of our unit circle values. Okay, now pi over 6, so let's draw this. So pi over 12 is a very small angle, about right here. Oops, sorry, not 12 degrees, but pi over 12 radians. And then actually pi over is twice that. So pi over 6 is actually twice that. And pi over 6 is actually the same as 30 degrees. Okay, so this little larger angle is pi over 6. Now, if you notice, this is actually in the first quadrant. Okay, so let's use, and let's actually use, we're going to do all 3 formulas just to see how they work. A over, sorry, the tangent of a over 2 is plus or minus the square root of 1 minus cosine a over 1 plus cosine a. Okay, now do that. And once again, figure out which sign we use. Okay, so pi over 12 is in quadrant 1. And also, of course, in tangent in quadrant 1, tangent of theta is greater than 0 in quadrant 1. Everything is positive in quadrant 1. So we're going to use the positive version. Okay, now let's plug everything in. And so we have the tangent of pi over 12 is equal to positive, I'll just leave it as a no sign, 1 plus the cosine of, sorry, it's minus on top, 1 minus cosine of pi over 6, and then 1 plus the cosine of pi over 6. Okay, now once again, if you go to your unit circle or use a special triangle, let's plug these in. So cosine of pi over 6 is this, it actually is square root of 3 over 2. So we'll use that value a few times a day, but still that's perfectly fine. So this is going to be 1 minus square root of 3 over 2, then 1 plus the square root of 3 over 2. Okay. Now, once again, we want to simplify this, very similar way we did before. So you need a common denominator in both cases. We want to combine our numerator and denominator here. That common denominator, of course, is going to be 2. So 1 is 2 over 2. So 2 over 2 minus the square root of 3 over 2. And then 2 over 2 plus the square root of 3 over 2. Okay, and then if we combine those, at the top, we have 2 minus the square root of 3 over 2. And then we have a low fraction, 2 plus the square root of 3 over 2. Okay, now multiply by the reciprocal of the denominator. And so we have the same numerator here, 2 minus the square root of 3 over 2 times 2 over 2 plus the square root of 3. 2's cancel out. And then this becomes, so we have the tangent of pi over 12 is equal to the square root of 2 minus the square root of 3 over 2 plus the square root of 3. Okay, and that's the exact value. Once again, let's approximate that, and we'll check it with Desmos. So do square root SQRT. Then let's use parentheses because we have to a fraction. So 2 minus the square root of 3, so SQRT 3. Use a cursor get from under the radical sign and use the parentheses there. And down here, the same thing except plus, so 2 plus SQRT of 3. And that, as you see, is about approximately 0.27. Okay, now let's try this. Let's actually go back to, let's change our mode and go to radian mode, and go back to radian mode. Just be careful what mode you're in. And then do the tangent of, in parentheses, pi, so just do pi, just type pi, divided by 12. And yeah, once again, exactly the same thing as it should be, approximately 0.27. Okay, now let's do it the other way. I'll just say here, I'll say, or let's use one of the other formulas, tangent of a over 2 is equal to, I'll use the second one, sine of a over 1 minus the cosine of a. 1 plus the cosine of a, rather. So always be careful of these formulas. Make sure you got the signs right. So sine of a over 1 plus cosine of a. Okay, let's plug everything in. So then the tangent of pi over 12 is equal to the sine of pi over 6 divided by 1 plus the cosine of pi over 6. Okay, plug those in. And so we have the sine of pi over 6. Once you can check your unit circle, it's going to be 1/2, and 1 plus cosine of pi over 6, as we used before, is the square root of 3 over 2. And once again, combine your fractions in the denominator. So 1/2 divided by 2 over 2 plus the square root of 3 over 2. And combine those. So 1/2 over 2 plus the square root of 3 over 2. Multiply by the reciprocal of this. And so we have 1/2 times 2 over 2 plus the square root of 3. 2's cancel out. And so we get that the tangent of pi over 12 is equal to 1 over 2 plus the square root of 3. Okay, now is that the same thing? Doesn't look the same, obviously. Well, let's see if that's the same value as this. All right, so plug this into Desmos, we'll approximate it, or use your graphing calculator. Okay, so 1 divided by 2 plus SQRT, then 3. Yeah, exactly the same. Okay. Approximately 0.27. Okay. Then last thing, let's do the other one. Let's do, say, or let's use the other version. The tangent of pi, or, well, let's do the formula first. The tangent of a over 2 is equal to, use the last version, 1 minus cosine of a over sine of a. Okay. Now, we plug everything in. We have the tangent pi over 12 is equal to 1 minus the cosine of pi over 6 divided by the sine of pi over 6. Okay, so plug those in. And we have 1 minus the square root of 3 over 2 divided by 1/2. And once again, same thing, combine, get a common denominator on the top, 2 over 2 minus the square root of 3 over 2. It's all over 1/2. And combine those fractions. So we have 2 minus the square root of 3 divided by 2 on top, still divided by 1/2, and multiply by the reciprocal of the denominator. And so we have 2 minus the square root of 3 over 2 times 2 over 1. And this just reduces to the simplest expression of all of them, which is, right there. So we have the tangent of pi over 12 is equal to 2 minus the square root of 3. Once again, let's make sure that gives us the same result. Now, if it looks different, as we'll see, actually do get the same thing. And so we do just 2 minus SQRT 3. And once again, exactly the same thing. So look at all 4 of these. These all 4 give us exactly the same result. Okay, approximately 0.27. So all give the same result. Okay, good. So that's as we expected, as it should be. You get the same thing from each. Okay, now this one in this case gave us the simplest expression, but don't count on that. Don't count on that happening. This just happened, probably just a coincidence. This one gave us the simplest expression. That's not guaranteed to happen again. But you can use any one of those 3 expressions, as long as you use it correctly, to find, to approximate the tangent of the angle. Okay. Of course, this one is a bit more difficult, just the sense you have to make a choice, determining figuring out which quadrant you're in, depending on which sign you use. What we learned then is just how to find exact values of a half angle if we know essentially the full angle. And so this can give us the exact values. Of course, you always approximate them in the calculator. In real life, that's what you do most often, but if you need to find an exact value, that's how we can do it if we know the cosine, sine, and tangent of the full angle. Thank you. Have a good day.